All right, Miss Slyman back again. Now we're looking at an arithmetic sequence. So it looks arithmetic because it looks like I'm always adding 3 each time. To show that it's arithmetic, I'm going to take a term and the previous term and subtract them. So 10 minus 7 equals 3. Now if it's arithmetic, that's going to be true for another set of terms. 13 minus 10 also equals 3. I could test one more time. 16 minus 13 equals 3. So each term has the same common difference. So sequence has a common difference. So that makes it arithmetic. And even more so, we can say that the common difference is 3. The general term, that's what we were talking about up here. So for any term, we're going to find it by taking the first term, so that's 7, and then 1 less than whatever number we're looking at, whatever term we are, and then we're going to multiply that by the common difference, which is 3. Now you can leave it like this, or I could expand and simplify. 7 plus 3 times n is 3n. Negative 1 times 3 is minus 3. So we could say 7 minus 3 is 4. So 3n plus 4 is another way to write it. So we can test this by looking at our sequence. So I see that the fourth term in our sequence, 1, 2, 3, 4, is 16. And I just randomly picked 4. I could have also tested 3 or 2 or even 1. So the fourth term is 16. That tells me if I plug in 4 to this formula, I should get 16. 3 times 4 plus 4, well, that's 12 plus 4, which is 16. So my formula is working. I could have also tested this formula. The fourth term is 7 plus, well, the fourth term minus 1, that's 3, times 3. 3 times 3 is 9, plus 7, that also equals 16. So either one of these formulas works as the general formula. Now I'm going to use one of those, it doesn't matter which one, to find the 100th term. So u sub 100, well, that's going to be first term plus 99 threes. Remember, it's always 1 less than the term we're looking for. So 7 plus 99 times 3, 297, and then plus 7, 304. So 297. So the 100th term, if I kept going all the way out to 100 terms, I would get 304. D. Is 58 a sequence? Is 58 a term of the sequence? If it's a term, that means it's going to happen down here, somewhere around here would be 58. If it is a term, then there's going to be an exact integer n to give me the term number, because I don't have partial terms. I have a first term and a second term and a third term and a fourth term and a fifth term, but I don't have a 5½ term. So n would have to be an integer. So actually, I'm going to use this formula this time. So I'm going to say that my nth term is 58, but I don't know what the n is. If it's an integer, then there is a 58th term. So using this formula, 58 would have to equal 3n plus 4, subtract 4 from both sides. 54 has to equal 3n. Well, let's do the subtraction. Or sorry, not the subtraction, the division. 54 divide by 3 does give me an integer. So then I would get that divide by 3, that n is 18. This tells me that the 18th term is 58. So that does mean that 58 is a term. Let's try it again with 92. So if I try 92, sorry, I obviously should have given you more space. So is there an n such that un is equal to 92? What would that n have to be? I'm going to use the same formula. If the 92nd term, if some term is 92, that means 92 is equal to 3n plus 4. Subtract 4 from both sides. 88 equals 3n. I know that no matter what I multiply 3 by, it never ends in 8. Never ever. I can test it though. 88 divide by 3, and I get a decimal. Of course, my term number cannot be a decimal. I can't have the 29th and a third term. So n is 29.3, but n cannot be in decimal. So 92 is not a term of our sequence. So, if you have questions about this, please come and ask them in class. Of course, we're going to come back and look at a few more examples. I'll see you in those videos.